Welcome back. In the last video, we saw the huge improvement to our server's response time that clustering can give us. But our cluster has its limits. Let's set up another little experiment. Continuing from our example in the previous video, if I open up two more tabs, and I open the network console in each of the tabs, making sure that disable cache has been checked off, let's see what happens if I go to the /timer endpoint in all of the tabs at more or less the same time. So I start it in the first, in the second, and refresh my two other tabs. I'm waiting around, and the request came back after 9 seconds in the first tab, 9 seconds in the second. In this tab, I went to the root endpoint instead of the timer by mistake, but we can see even the root took 6.5 seconds, and our last request to the timer took nearly 16 seconds, nearly double as long as it should have. Only 2 of our requests were made side by side in parallel. The other 2 had to wait because those processes were already blocked responding to the first request to timer. Notice the process IDs that we logged. In the first tab, we have a process with this ID ending in 29. Then we have 30 for the second request. And using our round-robin approach to dividing work, we can see that the third request reused the first process, and the fourth request reused the second process. Using clustering is not what we call a silver bullet, something that solves all our problems just by always taking the same approach. We're limited by the amount of processes that can execute in parallel. Right now, in our cluster, we've forked 2 processes, and we could only handle 2 requests simultaneously at the same time. That means we should keep adding these fork statements to create more worker processes, right? Well, there's a limit to how far this approach can take us. Let me show you what I mean. Let's be a little bit more clever and automate the creation of our forks. We're going to use the OS module, which is another node built in. So we'll say const OS equals require OS, which stands for operating system. And we're going to use the operating system to give us some information that will let us create the correct number of worker processes. You see, to run efficiently, each process needs to use a separate processor in your computer, in your CPU. In general, we want to limit the amount of forks that we create to the amount of logical or physical cores in your CPU. Physical cores are just that. They're separate processors in your computer that each handle work in parallel. Logical cores are a little bit more complicated. They use some fancy logic to let you run multiple threads in parallel on one physical core, but only in certain cases, and not as efficiently as a physical core could run your code. To maximize the performance of our server, in general, we want to take the amount of logical cores, which we can do by saying const number of workers equals, using our built-in operating system module, os.cpus, which gives us the amount of logical cores dot length. And we'll say for each of these workers, so let I equals 0, I is less than number of workers, and I++, we'll create our new fork. And I'll remove these extra statements. Now we're only creating the amount of worker processes which will maximize the usage of all of the cores in our server machine. That's what we want in the real world. So on my machine, I'll restart the server, and I have 4 physical cores, but 8 logical cores, which means I now have 8 workers. That means in my browser, I can make up to 8 requests at the same time and get increased performance. The 4 physical cores should allow our response to return for our timer in about 9 seconds, and the non-physical cores, so the 4 left over, might see some performance somewhere in between. Let's see. I'll make 6 requests in total. Again, opening the network tab, just to make sure that we're disabling the cache. And let's go. This time I'll make sure to hit the timer endpoint in all of the tabs over here. So first this tab, 2, 3, 4, 5, and 6. Let's wait around for the request to complete. All right, so we got the first request completing in 9 seconds, 9.06, 9.03, again about 9 seconds, and let's see how efficient the logical cores are on my machine. Looks like they're very efficient. It's possible my machine has 8 physical cores. That's a pleasant surprise. And the last request also took about 9 seconds. We're now maximizing the performance of our server based on the amount of CPU cores in our machine. Very good stuff.